Hello, welcome to this BrodieMaths video about transformations. I'm Andrew Brodie and I'll be talking to you today about translations and rotations. But before we do that, we've really got to know this grid very well. Obviously, you'd know where coordinates are to find points on the grid, but it's very important to understand the lines. So obviously that's the y-axis, that's the x-axis, but you might be asked to reflect a shape in the line y equals 2 or in the line x equals 5. So let's have a look at what those lines look like. For example, y equals 2. That means that we're looking all the way along here. That is the line y equals 2. Because if you pick any point, suppose we pick that point there, the x coordinate is 4, but the y coordinate is 2. Pick this point here, x coordinate is 10, but the y coordinate is 2. So that is the line where y is always 2. And so we can draw that line across there, and we can say that is the line y equals 2. Or the line x equals 5 is where the value of x is always 5. So quite obviously the line x equals 5 is that one there. And if we picked coordinates, you'd say, for example, that point there, the coordinates are 5, 4. This point here, coordinates are 5, -4. So that is the line x equals 5. Another one that's commonly used is the line y equals x. So that means when y is 1, x is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. When y is 5, x is 5. Y equals x. And that goes through the origin. And that is the line y equals x. And we really need to know those. The other one that might be worth looking at is y equals -x. That's one where, for example, if x is 4, y will be -4. So that's there. And again, that passes through the origin, but at right angles to the one we've just seen before. So there we go. That is the line y equals -x. So I've got a shape drawn on the grid, but I'm going to do a sketch copy of it. And I'm going to do that sketch copy over here. So 3 wide, 1, 2 along, 1 up. So there's my sketch copy. Now, what's happened to get that shape to there? This is what you will be asked. How do we map that shape to that shape? The easiest thing to do is to pick one corner. So I'm just going to pick that corner, and I'm going to see what's happened for that corner to move to there. So in the x direction, it's gone 1, 2, 3, 4, 5, 6, 7, 8, because we're lined up with it there. So in the x direction, it's gone 8, and then it's gone down 2 in the y direction. So we can say that this is a translation, and we have to use the word translation, of 8 in the x direction and -2 in the y direction. And we use this, which is a column vector. You could check with one of the other points. Let's do that one. So 1, 2, 3, 4, 5, 6, 7, 8, and down 2. And we've ended up there. That is a translation of 8, -2. Now, when you're dealing with rotations, it's really useful to have a piece of tracing paper. So I've got some tracing paper here, and I'm going to just trace the shape. Perhaps I'll put it further in one corner. I might get more use from my paper then. So just drawing, sketching it on. There's the shape. And you may be asked to rotate the shape around the origin. So we'd call the origin the center of rotation. And you may be asked to rotate it 90 degrees, in which case it's going to end up there, 90 degrees around the center of rotation, which is the origin. And so having spotted where it is, you can just lift the corner of your tracing paper, make sure you've got it in exactly the right place, and then trace it on. You can barely see my lines there, but I know they're there and they will be coming. So there is the shape, check it's in the right place. Yes, it is. And so that is this shape rotated around the origin as center of rotation. But let's do it again around a different center of rotation. Let's rotate it 90 degrees about the point 4, 3. So if we put the pencil point there, that's where 4, 3 is, rotating 90 degrees. And so again, as long as we're doing it in exactly the right place. So the shape has been rotated 90 degrees with 4, 3 as the center of rotation. Now we might want to rotate it 180 degrees. So let's start again. It's there. Let's make the center of rotation 1, 1, 180 degrees. So this is where the tracing paper is really useful, because you can see that's 90 and you can see that that's 180. So there it is. Just sketched on. So that is this shape after a rotation of 180 degrees around the center of rotation 1, 1. So if in the exam you're writing about it, and let's call this shape A, and we'll call this one shape B. To map A to B, we have to say, first of all, it's a rotation. You must use that word. It's 180 degrees. And the center of rotation was the point 1, 1. So that tells us how A gets to B. It's a rotation, it's 180 degrees, and the center of rotation is 1, 1. So we've got 3 facts, and you get 3 points in the exam. But there's a word that we ought to add, and that is clockwise. 180 degrees clockwise. Now, if we put the tracing paper back on, and as you've noticed, I used the pencil point to hold the paper, we went clockwise 180 degrees and we got to B. Now, interestingly, of course, because we went 180 degrees, get back to the start, we could have gone 90, 180 degrees anti-clockwise, and we'd have still got to B. That's why when we write 180 degrees, maybe the word clockwise is not essential. But look again at these two. Let's call this one C. How do we map A onto C? Now you'll remember that that was a rotation about the point 4, 3. There's the pencil point holding it, and we are rotating 90 degrees, but it is clockwise. If we went anti-clockwise, we get a completely different position. So to map A onto C, what we need to write is, of course, that it's a rotation. We would have to write 90 degrees clockwise. Let's move that over a bit so you can see it clearly. 90 degrees clockwise, the center of rotation was 4, 3, that point there. So rotation of 90 degrees clockwise about the point 4, 3. 3 points, that would give you 3 points in the exam.